There you are now. Welcome back to the workshop. So in today's episode, we are going to get back into some more work on the car building jig. The reason we're doing this today is because you wonderful people got involved during the week. I put up a community post asking whether people wanted to see more work on the jig or they wanted to see some other technical content. I think it was about putting a clutch in. And you all got involved. There was a really good response and I said, okay, so we're making more jig action today. We have a couple of things and I'm going to do something that I probably haven't done before, but I really want to do this now because you guys are always so active in the comments, and particularly on this jig building video, you came in with some just really brilliant ideas, some really interesting looks at things that I, in fairness, had missed or maybe hadn't thought about fully. So I'm going to just give a couple of shout outs and answer some of the comments. And also show you what we've done in relation to that. So frame squaring got a good bit of reaction. I was doing my 3-4-5 to check the corners, and a couple of you came back. Just to name a few of you: Stuart Palmer, Midge Lambert, Dave Elliott and Colin Fursman. Hopefully I got all your names right. You all came, or you all put a comment in about measuring corner ways from one corner of the square to the other, and you're absolutely completely correct. That is a completely accurate way of checking frame squareness, especially in something that is effectively a box. The reason why I did 3-4-5 and didn't do the corner to corner is because of this structural steel. So I bought structural steel as opposed to just mild steel because I wanted this to be stiffer. And structural steel has a sort of a profile to it, this kind of a round edge. It's not a sharp midpoint edge. Now, what I did to get around that was I used an old calipers, and I scribed a line through the middle of all of the box. Again, where that line intersected here at the cross, I certainly could have done the corner to corner measurement and got equally as accurate. But because of the way I was tacking this together on the floor, I wanted to kind of work from one side to the other. One of the things when you do corner to corner like that is oftentimes you have to move the whole frame a little bit one way and the whole frame a little bit the other way. I had this set up on shims. If you remember, I had it all shimmed up level on the floor. And I had a bit of a worry that I might move it off level when I was doing that. The 3-4-5 kind of just allowed me to move just any two pieces at once a slight little bit. But to be straight and honest with you, either would have been perfectly fine. I could have absolutely done that corner way. I just went with 3-4-5 because it's something I'm really, really familiar with, and it's a way of measuring square that I've always got on really well with and got really great results from. So that was the only reason I did that. Another shout out that I wanted to give was to Paul Pleshke and Gavin O'Sullivan, who mentioned about wheels. So in my drawing on the whiteboard, I said I wanted inflatable wheels at the back, and both of you guys, and maybe even somebody else, came on the channel and said maybe inflatable wheels, Paul's not a great idea, since that this is a jig that's going to have a lot of welding around it done, and an inflatable wheel with a little piece of hot molten metal will be soon an uninflated wheel, and that made me think, do you know what, you're absolutely right. So I went to my local supplier who does kind of casters and wheels and all that stuff, and he graciously showed me these wheels, which are what are called non-burstable or unburstable wheels or something like that. They're just solid rubber, so they're a real solid rubber, but they're still based on a wheelbarrow wheel, which is kind of the size I wanted, and I knew I kind of worked the maths out of my head. Now the great thing is the new design, or as the design of this jig has evolved, these won't actually be on the ground during any of the welding processes. They're only going to be put on the ground when we're moving the jig around or we want to go somewhere with it. So thank you so much for that, guys. Really good way of thinking. I also got a high temperature caster as well. So the wheels these are made out of is some form of nylon, which is better or more able to deal with high temperature. So and we also got one that was locking. Somebody DM'd me and said locking wheels on a jig would be a good idea just to stop it rolling around the workshop. So thank you very much, guys, for that. Final shout out from the comment section was for Andrew Price, who mentioned Project Binky, and I had completely forgotten that Binky did a bit of an overview of the jig they have for building their car. And thank you so much, because I went straight back there, had a look at some of the early episodes of Project Binky, and I got one really brilliant idea for a way of having this jig solid on the ground when I'm doing welding work, but also to make it adjustable so I can bring it into level no matter what floor I'm working on. I have a way of doing that. So I'm going to show you what we've done. It's definitely not the same as Project Binky, because you know, no two engineers think the same way, but I've definitely taken some of the ideas from it. So what I've done is I've gotten two different types of box. This is kind of on our old idea that we had before, where, you know, this is the box that slides over the frame of the jig. But I got to the notion that wouldn't it be great if the legs of the frame were adjustable, so they could come up or down to level the frame. So the solution for that is to have a leg that moves in and out of the box arm. So there's our leg welded on. We have a bolt down here at the bottom, and as we turn that bolt, we can see that the leg starts to climb. So as the leg moves out of the jig, we can then completely square it up. I've also made it so that that leg adjusts that length. So I can actually raise the jig off the ground almost that much. So I can raise the jig, they are 9 inches. So I can effectively, no actually sorry, they're 10 inches, and I can raise the jig 9.5 inches before it hits the stop. So I can actually get the jig from just slightly over 9 inches off the ground to sort of 18 inches off the ground, which is as high as you'd ever want the frame really to be. But it's also going to work really well because we're going to mount the wheels to this leg. So what can happen is we can lift the jig off its wheels completely by jacking this inner leg up, take the frame completely off its wheels and level it all out. And then when we want to move the jig around to bring it out to the shed or off to the painters or just move it around here in the shop, we can drop these legs down and it'll put the jig back down on its wheels. So I think in the true fashion of this channel, I want to show you how I made these legs, because there's a bit of interest in engineering that's going on, and the way it all comes together to make these adjustable, I'm going to show you how I did that. So let's get to it. The first thing to get this assembly together is the inner part of the leg, the rising up part of the leg. How it's made is with a couple of parts. So there's a flat piece of steel that's welded across the top of the leg. To that then is welded an M16 nut, and then we put that then with some threaded rod inside. So let's get this guy made first. Okay, that's that done. Let's get that now mounted onto the frame. I'll show you how I do that. Okay, so we're at the point now where we need to get the outer part of the leg mounted onto or welded onto the steel frame, onto the jig. But there's a couple of things to negotiate here. So what we're going to end up with is a piece of this threaded rod that's going to spin in this nut that we've welded on. And as it spins, it's extending the leg up, and as it spins in the other direction, it's pulling the leg down. So what's going to happen is the threaded rod is going to go through this box steel. It's going to get a washer welded on one side of it, welded around here, and it'll get the nut spun on down here and welded on as well, so that when this turns, it can't move up or down. So the only thing that can move is the leg up and down the threaded rod, because this setup here will be caught on the box. Now, I'll admit to you, the first time I tried to do this, I tried to do it all with measurements, measuring the center, putting holes in it and stuff, and it didn't move very freely. And I think I got a little bit of misalignment when I was welding the leg into place, or there's just a little, it's quite easy to get misalignment in the whole thing. Now, one way of getting around that would be to drill a slightly bigger hole all the way through the box so there was a little bit of play, But me being me, I didn't want that. I like it to be all kind of nicely tight fitting. So I came up with an idea, and the idea was this. I ground a little point onto the end of a small bit of that threaded rod. So I just have a kind of a pointy tip on the end of the rod. And that pointy tip, the idea behind that is that it can make a mark. So what I do is screw that into that nut. So now I have sort of a center finder, if you will, in the end of that box. And hold the leg where it's going to be welded using a couple of magnetic clamps. So all I'm doing is just lining the leg up so it's dead in line with the other one in the middle of that box. Getting this other magnetic clamp in here. I'm not normally a fan of these magnetic clamps, but it actually works for this job really well. Now, with my marker, I'm going to put a little bit of a mark there and one there, so I know where to put the leg back to. Now I have that stud in the end of this with a bit of a pointer on it. I can just drop that down inside there, and it will now have put a punch mark on the box steel where the hole needs to go for the threaded rod. So if we look here, you can just see the punch mark. I'll point to it here with my marker for you, so you can just see the punch mark that it's left me there. See that little mark there. What we'll do now is we'll give that an extra little punch with our center punch so that we can drill it on that center. So now I have a center drill to go to, and I can drill out that hole. My apologies, I forgot to switch my mic on for welding back on that leg. I really do apologize. But basically, you've seen in the video, all we did was we welded the washer on to the piece of threaded rod. We then put the box over the we put the outer box over the inner box, and we welded it on. I was saying in the video, and you can't hear it, so I'm going to tell you again, this outer piece is not structural. It's just a guide and support for the leg that moves up and down. So all the load is borne on the leg that moves up and down. The only other structure it holds is the wheel that's going to roll the frame around. So it's still really well connected on there in the four corners, and we got a really good weld around it, but it's not particularly structured. So yeah, all we have in there, as I said, is we've got that threaded rod, which we welded a washer around, which you've seen, and we're going to weld the nut the far side. Once we weld that nut to that threaded rod, it's now captured in the box section. So the threaded rod can't move. So when you rotate the threaded rod, it's going to wind on the nut that's in that leg, and it's going to cause that leg to go out. You can see it on the finished one here. I have the nut welded on this one. So what you see now is that with that nut welded on there, as I wind it around, you can see the leg is now moving up out of the frame because it's captured in there. It's got the washer welded on this side, and it's got the nut welded on that side. So the only way it can work now is for that leg to come up out of the frame. Here's something nice now. We got the caster mounted on here. We did this off camera because there's nothing magical to see here. We just cut a piece of box iron, at 45 degrees. We left a bit of a standoff on the caster, and we did that so it can fully rotate. So even with the leg extended, the caster can still fully rotate around, so we're not worried about it binding. We were originally going to just weld a piece of plate onto the edge of the box, but we thought, oh, hold on a minute, our caster will hit the edge of the leg, our caster will hit the edge of the leg that side. So now the caster can freely rotate around. You might be looking at these casters and thinking they look a bit on the skimpy side, and to be honest with you, at first I kind of thought the same, but the guy in the shop assured me that these are good for 150 kilos. So they have the ability to support 150 kilos, which is way more than we need. The only thing I probably will change in the future is I'd like a caster with a slightly bigger wheel, just that'll make it roll. It'll roll in the workshop here fine, but if you get onto some of the rougher terrain out in the yard, you know, going up to the store shed or whatever, this might struggle a little bit. The great thing is that we can easily add a bigger caster with a bigger wheel on here afterwards with no difficulty, maybe just welding on an extra plate. But we'll see how this one rolls, and we'll give you a bit of feedback on it afterwards. For the rear wheels, as I said, I went with this solid wheelbarrow wheel. It's probably a little bit overkill, but I just wanted something that would have a good ability to roll over, as I said, sort of rougher terrain. So these wheels actually come with an axle built in, which was brilliant. So all we did was we took that axle out, we welded the axle on here around onto our box section, and we kept the distance down here so that when our leg extends out, it'll have the ability to lift the wheel off the ground. So once the leg extends upwards, it'll lift the wheel off the ground and it'll isolate the frame so it won't move around in the workshop, and then we'll be able to level it up and get it where we want it to be. I suppose the main thing with it is that we want this jig to be simple, okay? I looked at some of the other setups out there and they had like lever actions to lever the casters into place and stuff like that. I just want this jig to be really simple. It's easy to construct and it's also easy to operate with the minimum amount of moving parts. So in this case, we really just have the 4 legs as our moving part. A couple of people asked me in the comments, would I paint it? And the answer is yes. I'm going to weld on that other wheel over there, and then I'm going to give the whole frame a coat of hammerite or something to that. I have some black paint in there. I think it might be like hammerite or something like that. And that'll be perfect. I'll give it a coat of that all the way around. It'll make it cleaner, nicer to work with, and it'll also give it an extra bit of safety. I hope you enjoyed the episode. I hope this has brought us to a better place. The adjustability of this is going to be really, really helpful. And in the next episode, when we are going to put Gretel into this, and that is the next episode obviously of Gretel, we're going to bring Gretel in and put her onto this setup, and then we're going to level it all out, get it so that we can have the frame level. Then we're going to start building all the different anchor points using the slotted on sections that we talked about before. Obviously we're going to have to strip the shell to do that. Somebody was asking me as well on one of the comments about will I be thinking about building in mounting points for, say, the door frame or places like that. Absolutely, great idea. I was jiving off of that, and I think that is something we'll definitely do. We'll build little arms and jigs that can go onto this, that we can bolt, say, to the hinges on the door frame to keep the door frames in square when we cut other sections out. I think it's a great idea. Other than that, guys, if you're new to the channel, you are very, very welcome. We're delighted to have you here with us in the workshop. You might have heard us talking earlier on in the video about the post I made in the community section, and in order for you to be able to get involved in those community posts, you've got to be subscribed, and then it will come up as a notification for you and you can have your say. I intend in the future, as this channel grows, to involve you guys more and more and as much as I possibly can. So I'll be asking for your input. So make sure, if you're new to the channel and you like what you see, to hit that subscribe button. For everybody else that has watched along the video, thank you so much for making it all the way to the end of another long engineering video. I really do appreciate all the watch hours that you guys put in. It really does help the channel. If you could give me a like, that also helps just for the algorithm to get more people to see the video. Other than that, we will see you guys on the next